So I want to do another example showing external costs and benefits, or what we call externalities. An external cost is any cost that falls on people other than those who pursue the activity. So when an electric company produces electricity, they also produce emissions or pollution, and they don't pay the cost of the people who breathe in that pollution and end up having to go to the hospital with emphysema or some other kind of ailment. So that's an external cost that the electric company does not pay. This is also called a negative externality. Externality is the name given to external costs or external benefits of an activity. There's also positive externalities, and those involve external benefits. So an external benefit is just a benefit in an activity received by people other than those who pursue it. The classic example of this are vaccines. So if I get a flu shot, not only do I get the benefit of not getting sick, but other people around me aren't going to get sick since I'm not going to get sick in the first place. So that's an external benefit, and that represents a positive externality. So externalities actually reduce economic efficiency. It turns out that people pursuing their own self-interest do not get us to the social optimum or the best outcome for society, as Adam Smith would have predicted. And so externalities represent what's known as a market failure. There are solutions to these externalities which may be efficient, either taxes or subsidies, which you can read about in your book, and I'll show you a little bit here. But when efficient solutions are not possible, then government intervention or other collective action might be used. So here's a scenario of a beekeeper. In one scenario, she's going to have her bees are going to represent a positive externality. In the other scenario, her bees are going to represent a negative externality. And assume that her neighbor is an apple orchard, or for Modesto, let's say it's an almond grove. And we know that bees pollinate almond groves and apple orchards. So if Phoebe, the beekeeper, was right next to an almond grove, she would represent a positive externality. The owner of the apple orchard doesn't make any payments to Phoebe. She just has to harvest the bees so she can make their honey and sell the honey for profit. So the bees provide a free service to the local farmers by pollinating their crops, but the reason that Phoebe's producing them in the first place is to produce honey for herself. So Phoebe is essentially giving away this service, and the private costs are equal to her private benefits, as I'll show you in a moment. The social costs are exactly the same than the social benefits, and so this says private costs are equal to private benefits, social costs are less than social benefits. And so what that's saying is the cost associated with this activity is equal for both Phoebe and for the society in general. There's no external cost here. But there is an external benefit. And so it turns out Phoebe is going to produce as long as her private costs are equal to her private benefits. But what's efficient is for her to produce where her private costs are equal to the social benefit. And so in a moment, I'll show you on a supply and demand graph how this gets an inefficient outcome. And what happens is when there's external benefits or positive externalities, then a rational maximizing individual is just going to produce less than the social optimum, strictly less. And that's because they're going to equate private costs and private benefits, not private costs and social benefits. So whenever there's a positive externality in equilibrium without any intervention, just if we let the market do what it wants, when there's positive externalities, we're going to produce too little of the good. Now let's assume that Phoebe, the beekeeper, is now next door to a kindergarten. And so if she's next door to a kindergarten and potentially a nursing home, now these bees are going to represent a negative externality. They're now imposing a cost on the students of the school and the people who are living at the nursing home that they're not being compensated for. And so this is an external cost, or what's known as a negative externality. So they're a nuisance to the neighbors, they're giving bee stings, and Phoebe is not compensating any party for these bee stings that they're incurring. So the private costs are going to be equal to the private benefits, but the social costs are now greater than the social benefits. And so the idea is, again, Phoebe is going to equate private costs and private benefits. But what she should be doing is thinking about the private costs and the social benefits. So since she's only going to think about her cost of raising the bees, not the cost of raising the bees and the cost to her neighbors, she's going to end up producing too much in equilibrium. And so whenever we have negative externalities, we end up producing too much relative to the social optimum. So when external costs are involved, which means we have a negative So let me show you an example of a negative externality. So this is going to be pollution using, let's see, quantity of tons per year. Let's say someone's producing steel. And so they're going to have a private cost and a private benefit. The private cost obviously is the marginal cost curve or the supply curve here, and the private benefit is going to be represented by the demand curve here. Now it turns out that in equilibrium, this firm is going to produce 12,000 tons of steel a year because they're going to equate their private cost and their private benefit. But in reality, there's external costs. So we have extra costs, say $1,000 a ton. That's the extra cost associated with the pollution that this company emits from producing iron or whatever this company's producing. And so the social cost is greater than the private cost. So in equilibrium, they're going to produce 12,000 tons a year, but what's socially optimum is for them to only produce 8,000 tons a year. And so again, when we have a negative externality, the firm is only going to think about their private costs. They're not going to think about the extra cost associated with their pollution. And unless the government intervenes in equilibrium, they're going to produce 12,000 when the social optimum would be 8,000. One way we can get around this is if the externality was $1,000 a ton, the government could tax this company exactly $1,000 per ton. And what that would do is it would shift their private cost curve up to the social cost curve because you'd be adding $1,000 per ton to their cost. And since that's exactly equal, they would end up producing the optimal amount in equilibrium if we taxed them. If we didn't tax them, then this triangle here represents deadweight loss. And so that's lost efficiency due to the negative externality. So the deadweight loss in this example is 2 million a year. We find that by using the equation 1/2 base times height. And so this triangle here has a base of 4,000 and a height of 1 million. And so if you take 1 times 4, that's 4 million, and divide it by 2, you're going to get this deadweight loss equal to 2 million a year. Now alternatively, we can have positive externalities. And when we have positive externalities, it's the private benefit that is less than the social benefit. And so in equilibrium, we would produce a QPVT, but if we have an external benefit, now the social benefit is going to be greater than the private benefit. Let's say this is a flu shot. And so I'm only going to buy a flu shot thinking about my private benefits and my private costs. What I should be thinking about, however, is that my flu shot is also going to benefit other people. But I don't care about that. You can't force me to care about other people when deciding to buy a flu shot or not. So in equilibrium, I'm only going to get this QPVT, but the socially optimal quantity would be right at this intersection of the private marginal cost and the social benefit. And so that is the social optimum at that location. And again, we have deadweight loss associated with positive externalities. In this case, the deadweight loss is this triangle here. And so I hope this example helped you understand the difference between positive and negative externalities. Positive externalities are when the external or the social benefit is different than the private benefit, and a negative externality is when the social cost is greater than the private cost. Positive externalities result in too little of the good being provided in equilibrium, and negative externalities, as we saw before, result in too much of the good being produced in equilibrium.